This conference is brought to you by CodeStack, React and React Native development experts.
Hello, welcome everyone. My name is Wojciech, and today I will talk about creating your VoIP applications in React Native. So I'll talk about basics. So we'll see how to start with the VoIP apps and what they really are and what problems you can meet during the development or of such kind of the app. So, but first things first. So, as I said, my name is Wojciech Kwiatek. I'm a CTO at Challenge. So we are creating the product, which is a business phone app. So you can find it on Challenge, that app. I'm a JavaScript developer, roughly 10 years now, and I'm also a trainer and mentor when it comes to this field. So when it comes to technology that I was involved in, I actually did most of the, it looks like I started with some jQuery, Ember, Knockout.js, and going through Angular 2, Vue.js, and yeah, of course, the React and the React Native recently. So I'm not only coding right now, I'm also trying to bridge the gap between the tech and business. So I'm also that guy who's actually checking if the business ideas are really doable and what kind of technology can help the business to grow. Okay, so you can find myself on a GitHub or on a Twitter. So here are the links. And yeah, let's start with the topic. So just as the beginning, so what actually is a VoIP app? So when we talk about the VoIP apps, you probably are thinking of something like Zoom, Messenger, Teams, WhatsApp, and Skype. So these are the main, one of the main apps that are actually used to connect two peers together. So basically, when you're calling someone, either with the audio or video, so it's basically done via the VoIP app. So it doesn't necessarily has to be a phone number at the other end. So it may be just the connection between two apps, right? So that's what most of them does, and they also are doing mobile apps. So this is something that we will try to see how to create such kind of app. So when it comes to some kind of the ingredients, so what do we need to create such an app? So I put here three things which I consider the main one. So the first is access to the hardware, so to the microphone or camera. So we need to get the permission from the user. We need to get the stream, the audio stream or the video stream from the user, and then we can process it later. So that's the very basic thing. So to somehow get the stream. Then the second thing is we need a connection between these two endpoints. By endpoints, I mean two users, two or more users, because it doesn't necessarily need to have to be like we have just two users. We may have a group call or something like this. So we need connection between the participants. So that's the second thing. And the third thing, which applies especially to the native apps, is that you need some way to communicate to the API that your phone is calling. So WhatsApp does it, some Hangouts or Zoom or Meet does it, that if someone calls you, they're showing you or your phone is ringing. So that's the third thing. So we need to somehow connect to the phone API to basically show that the call is incoming. So let's start with the first point. So we need a set of permissions. So the way I put it in as a separate topic, because recently Android and iOS are trying to protect their users, and they're trying to to give them visibility of what's going on with their devices. So yeah, a few years ago it was like, okay, on Android you get the permission for everything actually, and you could do whatever you want. But these times are gone, so now we need on both systems we need to ask for permissions, for specific permissions. If you want to use microphone, the user has to give you the access. And why this is such a problem? First, because the guidelines, especially on iOS, requires you to have a working app even without the permissions. So even if we have a calling app and user don't give you any access to the microphone, it still needs to work somehow. It may give some kind of information that, okay, you don't have access to the microphone, so please give it to us so we will be able to make a call. But yes, still it needs to be a working app somehow. The second thing is that there's something which is called the call screen on Android, and it sometimes may be different from device to device on how it looks like and how it behaves. So sometimes you may need to educate users a little bit more on how to give the access to that, because it may not be that simple. Like you can see on the screen that the app would like to access your microphone, and that's it. Of course, all of these permissions can be reversed. So it can be basically taken from you for the given app. So bear that in mind that you should always have a fallback on that, especially when describing to describe to the user what's going on. Okay, when we actually have a permissions, it will be pretty straightforward to get the audio stream. But to get the audio stream, we need some kind of solution to that. And thanks to the WebRTC, we can use it. So we'll talk about the WebRTC first when it comes to the JavaScript, because WebRTC actually has a lot of years right now. So it's like about 10 years, I guess. So actually, the WebRTC is for a long time with us. However, this year came the WebRTC 1.0. So this is also a good step because previously, when using WebRTC, you may hit a wall when it comes to the interoperability. I mean, like there could be different implementations of the same thing. For example, on Chrome and on Firefox. So the different APIs that the APIs could work in a different way. After this 1.0 version, it should not be a problem at all. So you probably will not need any kind of adapters, polyfills, and things like that to make WebRTC work on every major browser. What's also important to note is that actually every single browser, even the Safari on iOS or Opera on Linux, will work. So you can use WebRTC between actually most of the today's browsers. So, but yeah, let's talk a little bit on how the WebRTC connection look like, because usually what you can find on the internet is just like WebRTC is a peer-to-peer connection, and that's actually true, of course, but there's a little bit more behind that, because to have a peer-to-peer connection, you need to somehow discover these two peers. And this discovering these two peers, is usually done through some external server. But this external server are called stun and turn. These are the different technologies to achieve the same thing. I'll not go into the details when it comes to the stun and turn. I will attach the links at the very end, so you can read more about it. However, the idea behind it is that the WebRTC supports both of them, and both of them are basically to enable the connection between two peers. So to make them talk to each other. However, before you basically send the media between two peers, you will need to set up the connection, and that's where this middleware kicks in. Okay, so we have here some high-level implementation of the WebRTC connection. So first, we need to get and share local and remote descriptions. So it means that we need to share the metadata about the local media in some specified format. This format, we don't have to care about it that much because that's part of the WebRTC thing. But what we need to know is that we need to send our metadata about what's our local stream on one device to another device. So for example, what's the resolution? What codecs do they support? We need to push that information to the other party. And the second thing is to make our make the peers discoverable. So it's about the servers that we talked just before. So we need to get the information from the other peer and share the information about myself to the other peer. So it's called the ICE candidates. So we need to send this to get this candidate and send it to the other party. And as we have these two things, we actually will have the WebRTC connection. So it means we are allowed, or we know how to send the data. So the last part is basically send the data, which we get from the particular device for every single user. Okay, I'll try to share some code here. So this is like not the working snippet; it's more like an idea on how it could look like. Of course, the APIs here are the real ones. However, what we can see here, we can see the configuration object, which has an URL to the public SAN server. So it means you don't have to have your own server for that. You may need the Google ones, and that's actually pretty safe. But probably if you later on will use your own app, you may need your own server. But yeah, let's, for the example, take the Google ones, and you're creating the RTC peer connection with that, which means that this is the object that we will attach other information. So for example, here you have, I will put that later on. So this one, you will have the created offer from the peer connection. So we are creating the offer and we are setting this offer to our peer connection, and we are sending this through some sign-in channel. I omitted this one because there's a sign-in channel, which is kind of mock. When it comes to the WebRTC implementation or actually description, the sign-in link is not defined. It means this sign-in channel can be anything. So, for example, in this case, it's some kind of WebSocket thing, which sends to the Node server, and the Node server manages this sign-in link. So you have the send method to every other channel of the WebRTC, and also add event listener on the message. So yeah, let's go here. So we are setting the local description. We are putting this offer into the sign-in channel. Okay, so then we go to the receiver. We have the same thing when it comes to creating a peer connection, and we have the listener for the message with the offer. So we have we are taking this one on the receiver part, and we are setting the remote description. And as we set the remote description, we are creating the answer, and we are setting the local description with this answer, and we are sending the answer. So basically, receiver gets the offer, creates, sets the offer as a remote description, creates the answer, sets it as a local description, and puts the answer back. And back to the sender, we have add event listener for the message with the answer, where we are setting the remote description. So this was this first part about the negotiating the resolutions, the codecs, and so on. So the metadata about what can we send and what can we receive. The other part is that both sender and receiver are putting the listener to the ICE candidate, and this is what the stand server actually does. And we should, as we get the ICE candidate, we should send it to the other channel. Yeah, so we are sending from the one peer to another the ICE candidate, and as we receive it, we are adding the ICE candidate to the peer connection. And now, after these two things, this means that we have the networking set up, so we are allowed to send the media. So as we have the connection state changed here, the event listener for that, we can see that the connection state changed to the connected. Then we are good to go. We can send the media. Okay, things are getting complicated. So you can see that we just took a look at the very beginning of this, let's say, conversation. So we just set up the connection between the peers with the WebRTC. We didn't even send the media yet. So to be honest, the whole WebRTC is a very powerful tool, but it's definitely not that easy. And when it comes to the VoIP, there's something called session initiation protocol. So there's some very special protocol, and there are some tools built on top of that allows that works also on the top of the WebRTC that allows us to do things a little bit simpler. What I mean by that, the SIP can, or actually this protocol can set up a session between the endpoints. So what we already did between two peers of the pure WebRTC, it can negotiate the media parameters, the specs. So yes, one more time, exactly the same what we did. It can manage the session. So it can terminate the session, it can adjust the parameters during the session. It can substitute the tracks, for example, if you want to transfer the call to someone else, or if you want to use a different track. So for example, you put your headphones on. So all of this is already handled in some tools. So when I think of some tools, there are some JS libraries for that. So there is JS-SIP and SIP.js, when the SIP.js is actually a fork of JS-SIP. And they are creating a kind of abstraction over the WebRTC, so you don't need to care of every single thing which you would do with the WebRTC. What's more, it actually takes care of the signaling. So what it means that when we have this signaling server or whatever that was marked under the example, now all of this is being handled by the SIP server. That's also downside because you have to use a SIP server, but the upside is that it's already done. So there are some servers like Camelio, Asterisk, or FreeSwitch, and more of them even. So I would just name some popular ones to take care of the signaling thing, to take care of this negotiation, and so on. So what I'd say that if you want to use the cloud or you want to create a cloud telephony application, you probably will end up with the SIP on the top of the WebRTC. So, but I strongly encourage you, if you want to give it a try, let's start with the pure WebRTC and see where it goes, and then let's go to the SIP and see how it's different, how it's much more helpful with that. Okay, so the question is, if this signaling, if the SIP is enough. I would say for the whole application, it's not yet everything, because what we have here, what we discussed, is just a part of sending the media. So even though we started with the WebRTC with this initiation part, then with the signaling, it's still about the sending media. So you have the whole bunch of things that you would also want to send via the REST API, via GraphQL, or even via another WebSockets. So bear in mind that all of this that we are talking about, the signaling thing, is all about just the call, just the video or audio call. Okay, so we talked a little bit about the WebRTC, but where's the React Native in here? So the case is that thanks to React Native WebRTC library, all of this is also true for the React Native. So you can use all of this API also in the React Native app. So what's cool about this is that this package also takes care of polluting the global JavaScript namespace with the WebRTC globals. So for example, if the library like JSTip uses some global APIs like window.apps or WebRTC something, it's able to use it as in normal JavaScript application. So this package is pretty cool. So it requires some configuration step as far as I remember, but after that it's pretty smooth. So definitely should use that when it comes to the WebRTC. Okay, so now that's the time we can write the app, and that's true because after all of the steps, we can now make a connection between two apps. I mean, between the two instances of the app. So between the two users, we can send the voice, send the video, and all these technologies that we talked about up to this time should be enough. But there's one problem when it comes to the mobiles. What if the app goes background? Because this is the problem that we don't really have on the web apps, because usually they are done in the way that you're opening tab, you are doing something, even you are calling, you are having a mid conversation, you're closing the tab, that's gone. But when it comes to the mobiles, you put the mobile phone in a pocket, and then you actually wanted it to ring as it's required. So all the other apps are doing that, right? So WhatsApp is calling, when someone is calling you on WhatsApp, it's basically ringing as any other phone. So this is something that we want to achieve also in our app, right? So to achieve this thing, we would need two things. So the first one is the push notifications. Also, we have a slight difference here when it comes to the Android and iOS. So for iOS, we have two kinds of notifications. So we have push notifications and VoIP push notifications. The VoIP ones are meant to be used only for signaling the call. So for example, let's go back to the example. If someone calls you on WhatsApp, so the WhatsApp uses VoIP push notification to notify your device that there's an incoming call. On Android, on the other side, there are just notifications, and you are allowed basically to create such a call screen from any notification. Why is this important? Because on iOS, you definitely should use the VoIP because the priority of such a notification is much higher. And starting with iOS 13, it's actually strictly bound to the call screen. So let's talk about the call screens then. So with iOS 10 in 2016, Apple introduced something which is called CallKit. The CallKit is a set of APIs which allows you to communicate to your phone call system. By call system, I mean you can basically show call screen with your data, with your apps data. So and that's what main competitors or main companies are actually using right now. It was even more prominent starting with iOS 13, because starting from iOS 13, they actually forced you to use VoIP notifications with the call screen together. So every time the VoIP notification comes in to the iOS app, it needs to be reported as a call. So the call screen is being popped up. So the only way then to use it, you should follow the rule that you should use the VoIP push notifications only for incoming calls. And for the other, you should use the regular push notifications of the iOS. When it comes to the Android, you have the priorities. So we are managing this with priorities of notifications, and one of them are simply showing the call screen, while others are behaving like another notifications. Okay, but when it comes to the CallKit, there's a library which is called React Native CallKeep. And this CallKeep manages both CallKit on iOS and connection services on Android, which means that we can show the call screen on both Android and iOS using this package. So this is the package that probably is the only one on the market that will handle that without touching the native stuff in here. So I strongly encourage you to take a look at that when it comes to handling the CallKit and the connection services on Android. So this is how it looks like when it comes to the incoming call on Android. So we have basically our own screen, then the notification, which is the incoming call notification strictly from Android in this case. We are answering the call, and that's the call screen of Android. So that's what you can achieve using this CallKeep React Native package. Okay, so I bet now we covered all of the pieces that are needed to create such an app. Of course, this is a very sneak peek overview of what's going on here because yeah, there's a lot more underneath that. But I hope you get some very basic knowledge on where to start, on how these apps are actually looking under the hood. So just a quick recap. The first thing, think of permissions, because usually there will be more of that than just popping out the permission. You need to handle what's going on when one user denies the permission, basically. Second thing, I bet the only, or actually the preferred way, or it might be the only way to do is the WebRTC. So you need to incorporate the WebRTC into the React Native app, and you may or you may not use the zip and the zip server. However, it depends on your use case. So you may need some simple thing when the WebRTC, the pure WebRTC, will be enough. But if you need the whole signaling thing, the whole negotiation thing covered, then the zip is the way to go. The thing about the CallKit and connection services is very important when it comes to the background services, especially the incoming calls. So if you want to do the incoming calls properly, then you need to use the CallKit on iOS and VoIP push notifications. On Android, there are push notifications, just the casual ones, and you have the connection services, which allows you to show the incoming call or outgoing call using the native screen. And there's a package which is called React Native CallKeep to handle both of them. Last but not least, as you're starting to work on some kind of VoIP application, see if you really need to create it from the scratch, because there are some tools on the market, there are some SDKs on the market like Twilio. We are also entering the train as challenge the app. So maybe some part of these VoIP applications are already done. Even if it's paid, it might be even cheaper to create some sort of VoIP application using such already built solutions. So thank you very much, and I'll attach also the links to some additional resources. And yeah, see you hopefully next year in person. Bye.